Today we are going to talk about linked lists. A linked list is one of the simplest non-trivial data structures. So what I would describe as a particularly trivial data structure or a way of storing data is a simple variable. So you might want to store the number 10 somewhere in memory. So conceptually you have a box and you put a number in it, it's number 10. We want to refer to this as a thing called number. So we've got a box, we've put the number 10 in it, we've pointed the word number at it, so now we've got the number 10. We can change the value, we can add 1 to it, make it 11. We can do all sorts of things to it, but we've only got one number. So what do we do if we want to store multiple numbers? Well, so we've got this number that points to 10, we can have another variable called number 2 that points to 12, another variable called number 3 that points to some other number. But if you want to have 100 items of data, you want a more convenient way of storing that. You don't want to have to name each individual element because it's a pain.
And presumably not just that, you lose certain amounts of information about them, like their order or things like that.
Yeah, exactly. So you could theoretically store the order in the name, but then you've got to do horrible things in your program to look at the names and make the names meaningful. So instead of doing that, you can use a thing called an array, which is one name that points to multiple items of data, which we store next to each other in a contiguous block of memory. So if we want 100 numbers, we would store them one after the other in memory, and we know exactly how wide each number is going to be. In your programming language, your programming language will know how big a number is. So if it's an integer in C, it'll probably be 32 bits. So each number will be 32 bits wide in memory. So if we want to access the 10th thing in the list, we can just say, well, we know how big an integer is. Let's go 10 of that width along, and then bam, we found it. Arrays are okay. Arrays are okay. They're good for what they do. If you know exactly how many things you need, great. You can store loads of items. You can access them. You can access them efficiently.
What are they lacking then? So it sounds like they've got it all.
Well, arrays are only good as long as you know how many things you want to store. If you want to store an unbounded number of things.
What about, we've got a lot of traffic around, maybe you're counting how many cars cross a bridge at a certain time?
Yeah, so perhaps we're recording the time each car passes or the speed each car is going when it goes past, and we don't know how many cars there's going to be. We can make a best guess, but the problem is once that number is exceeded, we then have nowhere to put the data. We can make an array extendable, kind of. We do pay a slightly higher price for that. With an extendable array, typically you would double the size each time you needed to increase the storage capacity of it. If you do this, the cost of adding any element is constant. It averages out, so okay, on 2, 4, 8, 16, whatever, each time of those we've got to do a lot of copying, but on the times in between we don't have to do any, and it averages out to being constant.
So is that the best way to go about storing these lists then?
Well, so it's quite good because we still have constant time random access. We can pick an arbitrary element. So if you want to access the 100th element in an array, you can just say, well, I know the size of the things, I'll just skip 100 of those along in memory, and boom, there's my value. Linked lists don't have this property.